fluid, because there's either a gas or a liquid in each one, right? So fluid is the manipulated variable. Now, who can name one controlled variable in this experiment? There are several controlled variables. What's something that has to be controlled to make this a valid experiment? Nathan?
The thermometer.
The thermometers have to be the same, right. What's something else that has to be the same throughout, Emily B?
Same amount of fluid.
Huh?
Same amount of fluid.
Same amount of fluid. What's another one, Megan?
Same kind of jar.
Same kind of jar. Okay, that's enough. Those are all controlled variables. We know what the manipulated variable is in one word, but that's not very detailed. We have to get more detailed than that. Okay, so raise your hand if you think that the kind of fluid in the jars has anything to do with the result. You think so? Sure it does. How do you know that? How do you know that the kind of fluid has something to do with that result? How do you know that? Who can summarize why we know? Why do we know that, Jonathan?
Because it's in it.
He's trying to say the manipulated variable. The fluid is a manipulated variable. So therefore we know that the fluid has something to do. Now, let's identify what those fluids are. Is A blank? Yes. 2 is B blank? Yes. 3 is C blank? Yes. Just by looking at the problem in the chart, somebody in here should be already able to tell me what's in one of the jars. Tell me what's in one of the jars and which jar it is. What's in one of the jars and which jar is it?
Water.
You don't sound too sure of yourself. What, Emily H?
Air.
Which one has air in it, Emily?
C.
All right, who besides Emily H can tell me why she knows that there must be air in C? Why must she know that, Jonathan?
Because the temperature is.
The temperature didn't change. We already said we were measuring the air temperature in this one. The temperature didn't change. Good thinking, Emily. Okay. So, we already know that C has air, which is a fluid, but it's a gaseous fluid. All right, now I'll give you a clue about what's in A. It's a liquid. I'm sure glad nobody raised their hand yet. I did this yesterday and this morning, and when I said liquid, a bunch of people raised their hand. Why shouldn't you raise your hand? Why shouldn't you raise your hand after that one clue, Allie?
Because there could be a lot of liquid.
There could be a lot of clear liquids, like 10,000. How many do we want to narrow it down to before you guess?
1.
Stevie?
1.
1. Okay. It's a liquid. Oh, we have to take our next reading, our 5-minute reading. It's an A. B. C. 70. Does that surprise anybody?
No.
Why shouldn't you be surprised, Tanner?
It's just air.
Okay, we'll set it for another 5 minutes. All right. Oh, I turned it back too far. You're only supposed to turn it back to 5. All right. Well, okay, a clear colorless liquid. Oh, I just gave you 2 more clues. Clear colorless liquid. There it is. There it is. Clear colorless liquid. Who said water? How many clear colorless liquids are there in the world, Janelle? About 1,000. We've narrowed it down to 1,000 now, and Janelle thinks she knows. Your chances are 1 in 1,000 of being right. That's not a very good chance, okay? Clear, colorless liquid. Now this clue, because you've been here for my other focuses, this clue should tell a lot of you what this is. A clear, colorless liquid. If you drank that right there, you'd be dead in an hour. What is it, Chase? Yeah, rubbing alcohol. Rubbing alcohol. But I'm just going to put alcohol because there are a lot of different kinds of alcohols, but they would all give the same temperature pattern. Okay, I can start labeling these. A is air. No, A is, A is air.
C is air.
A is air, alcohol. C is air. Okay, now we have to find out what B is. Okay. B is a liquid. Why am I glad nobody raised their hand yet? Why, Emily?
Because there's a lot of liquids.
Lot of liquids. Okay. It's a clear, colorless liquid. Why am I glad nobody has their hand up yet? Jessica?
Because there's about 1,000 more.
Okay. Clear, colorless liquid. This is the clear, colorless liquid that we program our space probes to look for on other planets. What is it, Wyatt? Water.
No, we should guess.
Oh, that's hard. Totally.
Water.
Smart.
Who can tell the class why we program our space probes to look for water? Why, Kendall?
Because if there's water on the planet, there could be life.
If there's water, there could be life. Life as we know it requires water. Now, when you take high school biology, you're going to learn the characteristics of living things. Let's say there are 10 of them. That's just an arbitrary number. There's about 10. Okay. Well, one of them is that all living things need water, but there's 9 others. Well, suppose we find something somewhere in the universe, on another planet and another constellation, another galaxy, that has all of the first 9 characteristics of what we call life, but doesn't require water. Should we call it living?
No.
I don't know. I don't know what we should call it. It's pretty close. 9 out of 10 is pretty close. Well, it's possible that somewhere in the universe there's a kind of an organism that has all the characteristics of life, but it doesn't need water. Maybe it needs nitrogen, or maybe it needs alcohol. Who knows? All right. Well, that's a possibility for you to be thinking about, and someday we may find out the answer to that question. Okay. So this is water. So now I can write a beginning conclusion, tentative, because, and I'm going to put a colon after the because to indicate that I'm going to list 3 equivalent statements. A is alcohol, and any alcohol would give the same temperature result. B is water. C is air. Okay, that's reliable. Why is it reliable? Why is it reliable? Emily B.
The data doesn't
The
refute it.
data support it and they don't refute it. Okay. But what else do we have to say? What doesn't that list tell us that we need to know in order to explain why the temperatures vary that way? Allie? Huh? I can't hear you.
Set it up.
Oh, well, yeah, we need to know how to set it up. We know how to set it up. We can put alcohol in A and water in B and air in C, but what do we need to know about those 3 substances that'll help explain why these temperatures vary that way? Hold that thought.
I think that's all.
Okay, A. 59. B. 65. C. 70. Okay. All right. Okay, what did I just ask you? I lost my train of thought. What was I asking you?
I lost my train.
He lost his train of thought. Did everybody lose their train of thought?
She
Nobody
said
remembers
to
what I
set
was...
it up.
What?
She said
Oh,
to set
that's
it up.
right. Yeah, what's different about these three substances that could account for this difference in the temperature drop? Now, we have to know that, what's different about it. I'm gonna put it in the form of a sentence in the conclusion. Each of these has a different rate of now it's a long word. It has that many blanks. How many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Don't suggest a word unless it has 11 letters. Can anybody think of an 11-letter word? Each of these has a different rate of. Rate of what? Stevie? You don't know. Tanner? No.
I wasn't.
That's close. Brandon? Emily B? What, Wyatt?
Does it have an A in it?
Rate of, oh yes, it has an A in it.
Rate of.
Nobody knows. Okay, I'm gonna write it one letter at a time. If you can't see what I'm writing, this is how it's spelled. As soon as you know what it is, say it. E, V, A,
Elevation.
T, O, R, T, I, O.
Evaporation.
I'm not gonna put the last letter for anybody that doesn't know what it is.
And
They each have a different rate of evaporation.
Who said element?
Now, I'm not gonna write this, but I want you to remember this. This is an important universal law of science. The definition of evaporation. When a liquid changes to a gas, that's evaporation. All liquids can change to gases if you heat them high enough. So all liquids can evaporate. What's the most common familiar liquid that we've seen evaporate? Wyatt?
Water.
Water. Is there anybody here that's never seen water evaporate?
You've never seen water?
Have you ever boiled water?
I have.
Did you see the steam? Then you saw water evaporate. Okay, so once again, evaporation is when a liquid changes to a gas. Liquid water changing to steam, which is gaseous water. Okay, now that's the first sentence of the or that's the next sentence. Now here's another important sentence. Each of these has a different rate of evaporation. Okay, now it's getting better. It's not only reliable, it's better. Okay. When a liquid evaporates, it's okay to write this. This is going to be final. When a liquid evaporates, it absorbs blank, 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 blank. 4-letter word this time. Don't tell me water. Why? Because water is not a 4-letter word. Okay? What would fit in there, Shayla?
No.
It
absorbs.
It absorbs only? That's an incomplete sentence, Shayla. Okay, but it is a 4-letter word, Shayla. You're right. And it's not water. Okay. Jessica.
Life?
Live. It absorbs live. Does that make sense? Do you think that when a liquid evaporates, it absorbs life? If you stand next to the boiling tea kettle, are you absorbed by it? Okay. Well, you've given me some creative answers, but you haven't given me the right one. Nathan, what would it absorb?
Wait, no, it's not for
What?
Time down, Jessica.
Well, at least you're restricting your suggestions to 4-letter words.
Time to go shopping at the mall.
Okay.
Perfect!
Final reading. A, 56. B, 61. Raise your hand Raise your hand if you don't know what goes in there.
Who doesn't?
Okay, well, you all indicated that you know, so I'm gonna call on somebody to tell me what goes in that blank, somebody that hasn't participated yet. Janelle?
70.
You are
Wrong.
Because I'm so smart.
Oh.
Okay,
72.
now, that should go on the bottom of your record sheet, and that should go on the top, except we're not completely finished because we haven't filled in the 4-letter word yet.
It's late.
Joey, theme is a 5-letter word. Jonathan?
Tiny, we're shopping at the mall.
Yeah.
All right, look, I'm gonna give you a big clue.
Okay.
Tell you a story.
Okay.
Look.
Let's suppose that well, of course I have a lot of stories. When you get to be 78 years old, you'll have a lot of stories too, okay? When you're only 10, you don't have many stories, okay? Let's say that it's a really hot day, 90 degrees, that's a hot day around here. So you go with a couple of friends over to Clear Lake and visit somebody that's got a dock, okay? The air is 90 degrees, it's hot. The lake is only 70. So you jump in and immediately you get 20 degrees cooler, right? Because it's only 70. All right, now, that's not the end of the story. You climb back out on the dock, and when you get out on the dock, you feel even colder than when you were in the water. Why do you feel colder than when you were in the water? Who has figured that out? Emily B?
Heat? Your body heat.
Well,
That was mine.
she figured out the word, but she hasn't told me why you feel colder when you get out.
Because
Heat.
you're.
What?
Because. I don't know.
Well,
I know.
Emily got the right word, it's heat. Who can now explain why you feel colder when you get out? Megan?
Your body heat.
Well, you're close but not entirely correct. Who can figure out why you feel colder when you get out? Brandon?
Because your body is so used to the water that when you get out.
No. That's a very common answer, but that's not it. Chase?
When you jump in, then you're like blood.
We're not jumping in, we're getting out and we feel colder.
I know, but.
Okay, Allie.
When you get out of the water, you're still wet, and then the air that's not the water goes on you, and then the water just like makes you cold.
Well, you're closer. You're closer than Chase or Brandon were. Okay, Stevie?
Because of your body heat, like body temperature.
It changes
That
your
was an incomplete sentence. Complete your sentence. Okay, look. Look.
Oh.
You get out, you climb out of the water. You're still wet. You feel colder. Now everybody should be able to answer this next question. At what point do you stop feeling colder? Who can answer that? At what point do you stop feeling colder? Wyatt?
After a little while after the sentence.
When do you stop feeling colder, Janelle? When you're dry. Okay, you have a bundle of data here. Why do you feel colder when you get out and you're still wet? It's related to this focus. It's related to the universal law involved in this focus. Okay, Emily, you get another chance.
When you get out and then the heat goes on you, and then